Hello everyone, welcome to this problem. In this problem, you will receive as input an array of integer and an integer k. And the goal here is for each of the element, you need to find the sum of the k next element. Let's say, for instance, here k is actually 3, right? So let me get it here. K is actually 3. So for the first element, the element that will be at position 1 here will be the sum of the next 3 elements. In this case, is 7 plus 1, which is 8. 8 plus 4, which is 12. So that's why you have 12 here. Now, when you will be here, you need to find the sum of the next 3 elements, which is actually 1 plus 4 plus 5, because after this, the next element after 4 is actually 5. So 1 plus 4 plus 5, which is actually 9. And then now when you will be here, the sum of the 3 next element is actually 4 plus, no, this is 10. 5 plus 5, 10. And then when you will be at the third element is actually 4 plus 5, which is 9. 9 plus 7, which is 16. You have a 16 here. And then when you will be here, it will be the sum of those 3 elements, which is actually 8 plus 5, which is actually 13. That's why here you have 12, 10, 16, and 13. 12, 10, 16, and 13. So this is because the value of k is actually equal to a positive integer. K can be negative. If k is negative, you just need to find the k element before this guy. So if you're having k equal to maybe minus 3, when you will be here, instead of computing this plus this plus this, you will compute this plus this plus this. In this case, it's kind of giving the same value because the length is 4 and then you are going 3 elements. But what you should keep in mind here is the direction where you're starting and how many elements you're taking. Okay, so for us to solve this, we can directly go with the direct implementation of what we just described. So for each of the elements, you take the starting point, which will depend on if k is positive or negative, and then you move till you have k element and you sum those elements. Let us implement that and see what it will give. So this is what the implementation will look like. We will need to have like a vector of int that's going to be our answer. The guy we are going to return here. And then now we need to loop for each of the elements. So for each of the element, what you need to do for each of the element, just compute the k next element. And for that, we will need to have a temporal variable that will store those elements. And you know that it will depend on the value of k. If k is positive, is the next k element. If k is negative, is the k element before the index I. So you are going to have a check here. If k is actually greater than 0. So after this, I will show you an option to avoid this check, but let us go with this first to just have it done. So if k is actually greater or equal to 0, I don't know if this will work. Yeah. You now look for in g moving from 1, g is less or equal to k g plus plus, and for each of those elements, what you need to do is just to say prefer this val plus or equal to the code of which element I plus g modulo k modulo code.size. The use of modulo is just to say if I'm at the end, start back at the beginning. That's the use of the modulo here. So this is all what you need here for this one. And in the other case, if it's actually less or equal to 0, that means we are supposed to take the k element before. In that case, you need to have in g starting from -1, g is greater or equal to k g minus minus. And for each of those elements, what you need to do is val plus equal to code of. It's important for you to keep in mind that you are making I plus g, but the I plus g can be something negative. since it can be something negative, you need to add code.size here before applying the modulo. Yeah, so just adding code.size here before applying the modulo is enough, because the value of k, it has been set here, the value of k will not exceed n, right? If you are in a scenario where the value of k will exceed n, it will be better for you to compute the g modulo this, and then the result you add to the g and you apply the modulo again. So the role of this, you can consider this as a serialization to make sure that the value we have here will be always between 0 and the size of the array, so we are not finding ourselves out of range. So after this, you can just push the element here, and then let us run and see. Okay, we have an error. Why are you complaining? Okay, I'm missing something here. Premium. Okay, it's working. Let us submit. Perfect. Working pretty well. Okay, so this is one way of solving this. There's another way that I want to share with you. The idea is that, why is that I want to have those? Can I combine those two for loop into just one for loop? It will not actually increment, like make my algorithm better in terms of complexity, but that approach is also nice to know. So why am I using two separate for loop here? I'm using two separate for loop because I have one scenario where k is actually greater or equal to 0, and the other one where it's negative. So the idea here is to make sure that I can handle both of those cases in one for loop. And if I want to do so, how will this one look like? So the value of this guy will be actually equal to I plus g plus, like, this one is actually good enough. What I'm using, if I'm using this here, you will see work. So this one is actually good to handle this and this. Nice. So now the second thing we need to pay attention to is this one is incrementing, whereas this one is decrementing, right? So for us to handle this, we can have something here that we are going to call like a start or a direction, and the start is actually going to be equal to, if k is actually greater than 0, then you are going to take a 1, otherwise you are going to take a -1. So this guy can already be used as this one because is already -1 or +1, depending on if you are incrementing or decrementing. So we can say here that g plus equal to our start. This is actually handling both this case and this case. Now what is missing is only the starting point. This one is starting at -1 and this one is starting at 1. So how can we handle that? For each of the case, what we can do is that we can have something that we are going to call g here, that is going to be start. So this one has been handled also. This one has been handled. This one has been handled with this. So we were able to merge those two. This one has been handled. The only thing now which is missing is this condition. And this one is a little bit tricky because you have this one is, you have two types of evolution. Either you are moving incrementally or you are moving decrementally. Let's say, let me take this one. For this one, let's say for the first element, we are moving from position 1 till position 3. So let's say we want to move from 1 to 3. At the moment that g minus k is less than 0, is less or equal to 0, then we are still in this range. You do agree with me? Yeah, because when g will be 1, we have 1 minus k, which is actually a negative number. When g will be 3, we have 3 minus 3, which is 0, which is a 0, so it's actually valid. But when g will be 4, it will break the loop because 4 minus 1 will give a 1. So you do agree with me that we can directly have a condition saying that if g minus k is actually less than or equal to 0, then you break. But now in the case of decreasing, when you are moving from, if you are starting maybe at -1 and you are going to move till -3, in the case where it's negative, in that scenario, you instead want the g minus k to be greater or equal to 0. Or differently, you want the negative value of g minus k to be actually less or equal to 0. And this is actually interesting because we're able to have like the same, just one way of computing here, g minus k less than or equal to 0, or the negative value of g minus k less or equal to 0. In this scenario then, this -1 can come from the start. So what you can have is you can directly have a while here. I say can come from the start because if it's positive, the start is 1. 1 time this is the same. If it's negative, the start is -1. So you can use the start. So you can have something like start times g minus k, which is g minus k is actually less or equal to 0. With this, you don't need these two elements. So let us run and see. Working. Let us submit. Nice. See, performing pretty well. But now just with one loop. There's also another approach that you can use because the time complexity of this algorithm still remain n times k. There's another way you can use to make it just big of n. And for that, you can compute the first occurrence of the first k element. And now for each of the occurrence here, instead of recomputing the element you are computing over and over again, you just add one element and remove one element. So you add the element that is coming into the range and you remove the element which is getting out of the range. And that is also one interesting way. I'm not going to dive into that one here, but I'll be happy to interact with you regarding this. Feel free to give me a thought in the comment section. Ciao.